Saturn, the sixth planet from the Sun, stands out in our solar system for its striking and extensive ring system. With a diameter of approximately 116,460 kilometers, Saturn is the second largest planet, only surpassed by Jupiter. This gas giant has a distinctive appearance due to its large size and low density. Saturn's unique characteristics and its intricate system of moons make it a central focus for astronomical research and exploration. Saturn's physical characteristics are dominated by its iconic ring system and gaseous composition. The planet has a yellowish-brown hue, resulting from its atmospheric composition of hydrogen and helium, along with trace amounts of methane, ammonia, and other gases. Saturn's rapid rotation causes it to have an oblate shape, with a noticeable bulge at its equator. The planet's low density, less than that of water, indicates its composition is primarily gaseous, with no solid surface. The rings of Saturn are its most recognizable feature, consisting of countless small particles of ice and rock. These rings are divided into 7 primary groups named alphabetically in the order of their discovery: A, B, C, D, E, F, and G rings. The particles within the rings vary greatly in size, from microscopic grains to chunks as large as houses. Despite their vast expanse, the rings are incredibly thin, averaging about 10 meters in thickness. The composition of the rings, mainly water ice with some rocky debris, reflects the light, making them visible even from Earth. Saturn is composed predominantly of hydrogen, about 96%, and helium, about 3%, with trace amounts of other elements. The planet lacks a true solid surface, transitioning smoothly from its gaseous outer layers into a dense core thought to be made of rock and metallic elements. This core is surrounded by a thick layer of metallic hydrogen, which contributes to Saturn's strong magnetic field. The overall structure of Saturn is similar to that of Jupiter, but with a lower density and different atmospheric dynamics. The atmosphere of Saturn is composed mainly of hydrogen and helium, with clouds formed from ammonia, ammonium hydrosulfide, and water. These clouds are organized into bands parallel to the planet's equator, driven by powerful east-west winds. These winds can reach speeds of up to 1,800 kilometers per hour, significantly faster than the strongest winds on Earth. The atmospheric pressure and temperature increase with depth, leading to layers with different compositions and properties, contributing to the planet's complex weather patterns. Saturn's weather is characterized by extreme conditions and dynamic phenomena. One of the most notable features is the Great White Spot, a massive storm system that occurs roughly every 30 Earth years. This storm is comparable to Jupiter's Great Red Spot but is shorter-lived. Saturn also hosts long-lasting polar vortices and a peculiar hexagon-shaped storm at its north pole, which remains a mystery to scientists. These storms, driven by the planet's rapid rotation and atmospheric dynamics, create a visually stunning and scientifically intriguing spectacle. Saturn generates a strong magnetic field, although it is weaker than Jupiter's. This magnetic field is produced by the motion of conductive materials within the planet's liquid metallic hydrogen layer. The magnetic field extends far into space, trapping charged particles and forming radiation belts similar to Earth's Van Allen belts but much more intense. These belts can pose challenges for spacecraft operating near the planet, necessitating protective measures to shield sensitive instruments from radiation damage. Saturn is orbited by 83 confirmed moons, each with unique characteristics. Titan, the largest, stands out due to its thick atmosphere and surface lakes of liquid methane and ethane. Enceladus, another significant moon, is known for its geysers that eject water vapor and organic compounds, hinting at a subsurface ocean. Other notable moons include Rhea, Iapetus, and Dione, each offering unique insights into the geological and atmospheric processes at play within Saturn's extensive moon system. Titan, Saturn's largest moon, is remarkable for its dense, nitrogen-rich atmosphere, which is similar in composition to Earth's primordial atmosphere. Titan's surface is diverse, featuring lakes, rivers, and seas of liquid methane and ethane, as well as vast dune fields and mountain ranges. The Huygens probe, part of the Cassini-Huygens mission, provided detailed images and data from Titan's surface, revealing complex weather patterns and geological activity driven by its thick atmosphere and low temperatures. Enceladus is one of Saturn's most intriguing moons due to the presence of a subsurface ocean beneath its icy crust. The moon's south pole features geysers that eject water vapor, ice particles, and organic compounds into space, suggesting hydrothermal activity on the ocean floor. These discoveries, made by the Cassini spacecraft, have made Enceladus a key target in the search for extraterrestrial life, as its ocean may harbor the necessary conditions for microbial life. The Cassini-Huygens Mission, a collaboration between NASA, the European Space Agency, ESA, and the Italian Space Agency, ASI, significantly advanced our understanding of Saturn and its moons. Launched in 1997, the Cassini spacecraft spent 13 years orbiting Saturn, capturing detailed images and data on the planet's rings, atmosphere, and moons. The Huygens probe, which landed on Titan in 2005, provided the first direct observations of Titan's surface, offering unprecedented insights into its composition and weather patterns. The origin of Saturn's rings remains a subject of scientific debate. One prominent theory suggests that the rings formed from the debris of a moon that was shattered by a comet or asteroid impact. Another theory proposes that the rings are remnants of the early solar system, consisting of material that never coalesced into a moon. Recent data from the Cassini mission suggests that the rings may be younger than previously thought, possibly only a few 100 million years old, adding another layer of complexity to their origin story. Saturn experiences seasons similar to Earth, but each season lasts over 7 Earth years due to Saturn's long orbital period of 29.5 years around the Sun. These seasonal changes affect the planet's atmospheric conditions and the appearance of its rings. For instance, the rings become more visible during Saturn's equinoxes when they are tilted toward the Sun, allowing sunlight to penetrate and illuminate the ring particles more effectively. Seasonal variations also influence the dynamics of Saturn's storms and cloud formations. Saturn has been observed since ancient times, with records dating back to the Babylonians and other early astronomers. The invention of the telescope in the early 17th century allowed astronomers to study Saturn in greater detail. Galileo Galilei was the first to observe Saturn's rings in 1610, although he did not recognize them as such due to the limited resolution of his telescope. It was Christian Huygens who, in 1655, identified the rings as a disk surrounding the planet. Advances in telescopic technology have since allowed for more detailed observations of Saturn's atmosphere, rings, and moons. Saturn has held a significant place in various cultures and mythologies throughout history. In Roman mythology, Saturn is the god of agriculture, time, and harvest, often associated with the Greek god Cronus. The planet's name and its association with cycles and time are reflected in the word Saturday, named after the Roman god. Saturn's influence extends to literature, art, and popular culture, symbolizing both the beauty and mystery of the cosmos. Future missions to Saturn aim to further explore its moons and ring system, building on the discoveries made by the Cassini-Huygens mission. One such mission is NASA's Dragonfly, scheduled to launch in the mid-2020s, which will send a drone to Titan to study its surface and atmosphere in detail. Additionally, missions focused on Enceladus are being proposed to investigate its subsurface ocean and potential for life. These future explorations promise to deepen our understanding of Saturn's complex system and its potential for harboring life. Saturn and its moons provide valuable insights into the formation and evolution of our solar system. The planet's ring system offers a natural laboratory for studying the dynamics of disk systems, which can inform our understanding of planetary formation. The diverse environments of Saturn's moons, particularly Titan and Enceladus, present unique opportunities to study prebiotic chemistry and the conditions necessary for life. Saturn's weather patterns, magnetic field, and atmospheric dynamics also contribute to our broader understanding of planetary science. Exploring Saturn and its moons presents numerous challenges due to their vast distance from Earth and harsh environmental conditions. Spacecraft must be designed to withstand intense radiation, extreme temperatures, and long-duration missions. The travel time to Saturn, which can take several years, requires reliable and durable technology. Additionally, the complexity of navigating and conducting scientific operations in the vicinity of Saturn's powerful magnetic field and dense ring system adds to the difficulty of exploration missions. Technological advances have been crucial in enabling the detailed exploration of Saturn. The development of sophisticated instruments, such as those on the Cassini spacecraft, has allowed for high-resolution imaging and in-depth analysis of the planet and its moons. Long-duration spacecraft capable of withstanding harsh space environments have been essential for conducting extended missions. Advances in data transmission and analysis techniques have also played a key role in interpreting the vast amounts of information gathered from these missions. Saturn remains one of the most fascinating and complex planets in our solar system. Its majestic rings, diverse moons, and dynamic atmosphere continue to captivate scientists and the public alike. As our technology and knowledge advance, further exploration of Saturn promises to unveil more secrets about this remarkable planet and its place in the cosmos.